So we're going to do a little tour of the DAS solution that was installed here at the Hyatt Regency. It was installed a few years ago as part of the expansion to the Hyatt. It's about 700,000 square foot. The system costs somewhere a little under $700,000. So easy to calculate the dollar per square foot there, which is kind of the rule that typically gets used when people say what's the budget for a DAS. The system has about 160 antennas. So here's one of the antennas. So these antennas are broadband antennas. They're designed to go from the 700 megahertz all the way to about 5 gigahertz, which is typically your Wi-Fi range. So they're designed to handle a broad band of frequencies so that you can, in the future, you can connect more services to the system. And as time goes on, the antennas are getting more and more sophisticated. They're handling broader bands. You'll hear things like SISO and MIMO in the future. These are all SISO. This building is designed, this was designed before MIMO, or multiple antennas per path, started becoming something that was done. Although it will handle 4G, it just won't do it with MIMO. The head end is really where everything happens. This is where all the different signals come into the building. It's kind of like a multiplexer, if you will, right? So you have public safety, multiple public safety frequencies. You have multiple cellular bands, and who knows what the future is going to hold for the different signals that are going to come out in the future. The head end is designed to be modular so that it can grow, and you can even add boxes so that you can add more signals into the system. It's designed to be a true multi-band, multi-operator solution. The power is getting to those remotes over what's called a composite fiber cable. There's actually 14 gauge copper in the fiber cable that runs DC power to those remote locations so that they can all be powered from this central source. That's a really nice way to power your system because you have a lot more control over your power. The fiber comes into the demarcation here, which is a patch panel, and then there's also power that comes from that. So the power and the fiber is split off here in this box, and the fiber strand goes into the bottom of the system right here. So it's one strand of fiber for all frequencies. So everything from the public safety, low frequencies, all the way to the high frequencies is on one strand of fiber into the system right here. Now power comes in right here, and that's split off from the fiber in this box right here. So this is the DC power coming from downstairs. So you won't notice it plugged in the wall or anything. So once you have fiber and once you have power, you are basically ready to distribute the signal that's coming across that fiber. That fiber is distributed out of the system across this single coaxial cable output. That coaxial cable output then goes out of these splitters and goes to all the different coax cables on the floors. So you'll notice we have 8 antenna cables going out of this remote closet. And Dwayne, is Dwayne here?
Serves 2 floors. This one.
2 floors. Oh, there you are. Yeah, so this serves 2 floors. So 8 antennas, so 4 antennas per floor. Just to give you an idea of how much coverage you can get. And remember, the higher the frequency, 1900 megahertz, 2100 megahertz, the higher the frequency is, the less coverage you're going to get. So that that's kind of how you need to plan for the design. So basically, this box contains the amplifiers, the power supply, the brains, these big gray modules are the filters. They're called cavity filters. Every remote in the system, for example, Solid puts a test report just in case any parts need to be RMA'd. We actually have the test report with serial numbers in the system. Just makes for maintenance and troubleshooting simplicity. The system is designed to be completely sealed and watertight. That's actually part of the fire code. Why is that? Well, because there are sprinklers in these buildings, and when the sprinklers go off, if this thing wasn't watertight, the system wouldn't work very long. It would be shorting out. So there's a reason why the DAS has to be watertight, and it has nothing to do with cellular services. It has to do strictly with public safety. So the fire department has their radio tower, and so in order to capture that signal, we're picking that up with the antenna here that's pointed directly at that, which is the panel, and we're picking up the signal and bringing it into the building. And so we're doing that here with the Sprint services, and we're doing that with the public safety services at this point.